Hey Science 9, it's Mr. Glum again, and we're going to be starting a new unit, and it's going to be our electricity unit. So the first part of electricity unit is that we're going to be starting with static electricity. So the word static means not moving, and electricity or static charge means a buildup of electrons, or electrons kind of in an area. So what it means is that if you have an object, so let's have an object right here, and we have a whole bunch of electrons that kind of build up right here, then this would be electrons that are not moving, so they're static, and they have a charge, so this is what a static electricity is, or a static charge is. So if an object has a negative charge, that means electrons have built up inside of it. Now, if you remember from our chemistry unit, electrons are negative. So electrons are negative. Okay? So what that means is that as we know that like objects are made up of many atoms. And if one of those atoms has an extra electron, so for example, like say if we had chlorine, right? We've talked about chlorine, and if chlorine has an extra electron, we write chlorine minus right there. And if we had like an object with a whole bunch of extra electrons, what is going to happen? All those electrons that are added to it, it's going to give it an overall negative charge. So electrons have built up inside it, it gives a negative charge. If we had something that was like calcium and we had electrons taken away, and that gives it a 2+ charge, just like in chemistry, then that's going to make it positive. So if an object has electrons taken away, it's going to be, it's going to become positive. Okay, so we're going to talk about a lot about static electricity and kind of go from there. Anyways, so a neutral object, again with static electricity, a neutral object is when you have equal amount of positive and negative charges. So most objects that you're coming in contact with is a neutrally charged object. If something is positively charged, then that means it has more positive than negative components in it or atoms in it. That's what gives it an overall positive charge. If something is negative, that means it has more negatives in it than it has positives, so that we have an overall negative charge. Now, you are probably neutral. Now, if you ever come into contact with something that is charged, then you will see a little jump of electricity, or in other words, you'll get a little mini shock. Now, most of the time you are neutral, but not all the time. So say if you are walking through your house and you have wool socks on and you're walking on carpet, what happens is that those socks right there, you might be picking up a whole bunch of electrons, and then you yourself have lots and lots of electrons built up throughout your body. And then when you go and you touch something, so say if you touch your younger sibling, they are neutral. Okay, so they have equal number of positive and negative, and you touch them, all of your electrons will jump to them, and then they will have a shock, or you'll both receive a shock. Okay? Or if you get a shock from something else, and that means maybe that object was charged. So, in going with static electricity, there's a couple of different laws that we need to talk about. So, well, there's just one law, but some iterations of it. So the law is the law of electrical charge, and it says essentially same charges repel. So if you have a positive object, another positive object, okay, that they will not be attracted from each other, that they will want to push away from each other. Okay, kind of like when you have magnets with the two north poles facing each other, they'll kind of want to repel each other. So, or if you have two negative objects, they'll also want to push away from each other. Okay, so same charges repel. Now opposite charges are going to attract. So if you had a positive and a negative object, they're going to want to attract to each other. This is a huge portion of actually chemistry and ionic bonding. That's why sodium Na plus is attracted to chlorine minus, because it's a positive and negative charge. And that is the whole basis of ionic bonding, is that the opposite charges attract. Okay? Now, a neutral and a charge attract. So say if we have an object with no charge and an object that is positive, okay, they will want to attract. Okay? Or if you had something with no charge and something that was negative, they will want to attract. And we're going to look at an example of this. Okay, so here is a video with Bill Nye, and so we'll take a look at this little video right here, and hopefully we'll see some of these things that he talks about.
Oh, hi. Rub a balloon on your hair and bring it near another balloon hanging by a string. There's an invisible field pushing the two balloons apart. When you rub the balloon on your hair, you're transferring electrons from your hair onto the surface of the balloon. Now, the balloon's made of rubber. Electrons don't flow through it the way they do through a metal wire. Instead, they stay on the surface of the rubber. We use the word static electricity, which means electricity that stays. Now, different materials have different properties. Here's a stiff rubber rod and a piece of fur. It's like rubbing a rubber balloon on my hair. It also will push the balloon away. But watch what happens when I use the same piece of fur and this glass rod. It pulls the balloon toward it. So in the first case, we say they have like charges, like static charges, so they repel. In this case, they have opposite static charges, so they attract. You can try different materials and different experiments. Here's some rubber making scraps of paper jump around. It's fun. Or you can try two at once. Here's a repelling rod and an attracting rod. Repelling, attracting, repelling, attracting. I'm experimenting.
Hi, I'm Joanna.
And I'm Steve.
And this is a piece of PVC pipe.
And this is a plastic cup that has a hole drilled into the bottom of it. So when I fill it with water, it leaks out of the bottom.
If I charge the pipe and then bring it close to the stream of water, the water is attracted to it. That's because water molecules are polar molecules.
Water molecules look a little bit like Mickey Mouse. The two hydrogen atoms are bunched up on one side of the oxygen atom. And while the molecule itself is neutral overall, it has a positive end and a negative end because of the way it's shaped. Molecules, like water, that have an asymmetrical distribution of charge are called polar molecules.
Let's say the pipe has a negative electrical charge. If I bring it close to the stream of water, the water molecule flips so that the positive end is pointed towards the negatively charged pipe. Opposite charges attract, so the water is drawn towards the pipe.
This is an experiment you can do for yourself at home fairly easily. All you need to do is turn on the faucet so a little bit of water comes out, and then you place a charged object near the water. Any object that'll hold a charge will do, like a comb.
Or a balloon that you've rubbed on your head.
Or a plastic pen.
Thanks for watching. I hope you'll join us again soon for another experiment.
Okay, so hopefully this thing is still recording, but anyways, So that brings us to our next thing that we're going to talk about is insulators and conductors. So in an insulator, electrons can go through these objects very well, like plastic, rubber, glass are all good insulators. So cannot go through these objects very well. So in other words, what that means is that if you have a piece of plastic and you build up a whole bunch of electrons right here, they cannot travel down. So if you're holding this with your hand, okay, so there's your hand right there. These electrons, if you're holding this plastic rod and you build up electrons right here, they cannot travel down and then go into your hand. But if you are holding a metal rod, so say if this was metal, these electrons would easily go down through here, and the electrons would go into your hand. So this is one of the reasons why wires in a home are usually made out of copper. It's because electrons can go through these objects very, very quickly and easily. Metals are good conductors like copper, and that's why it's used. Because we want, in a house or at a school or wherever, we want electrons to get from one place to another so that we can power motors and we can turn on lights and all that kind of stuff. Insulators, we don't want electrons to go through those objects. So this is why usually wires are usually wrapped in things like plastic or rubber, because we don't want the electrons to be going outside of that object. So they will keep those, they won't allow conduction to occur. So when you're at home, I think it'd be a neat experiment to do what they did. In your kitchen sink or your bathroom sink, turn that on so it's a small stream of water that is coming out, and then what you're going to use is you're going to use like a polyester shirt or like a nylon kind of shirt or something, and rub it with a plastic pen and see if you can bend the stream of water like they did in the video. Now, the next thing is I want you to try using something metal like a screwdriver, and then kind of tell me what you found. Now, since I'm not there, normally I would get you to do this experiment in the classroom, but what we should see is that if here is your faucet and a very thin stream of water is coming out right here, if you bring a plastic pen close to this object, just like the video, this will attract because the water is neutral right now, and what they said in the video is that it has half of it is positive and half is negative. So the hydrogens are positive and the oxygen is negative, but that just makes it neutral. And then this pen would have a charge to it, and so it'll bend the water kind of like this. It'll bend it towards it, and then gravity will still pull it down. So that's what will happen there. Now, what happens if you use something that is metal? Well, if you rub the metal with this would say have a negative charge. So there's a whole bunch of negative charges in there, and that's why it bends this water stream. When you have a metal rod right here, what happens is that metal rod, all the electrons that you put into there by rubbing it with the polyester shirt, all the electrons are going to go down the metal rod into your hand or into wherever. They're not going to be inside of this metal rod, and therefore this thing is not going to bend at all. It's just going to go straight down, because metal is a conductor and plastic is not a conductor, it's an insulator. Okay, so plastic is really good at holding static electrical charge. Metals are not good at holding static electrical charge. Metals are good at conducting electricity, and that's why we use them in houses. Anyways.